Mailinator is a project I started a very long time ago with no particular purpose in mind, and it sort of has grown all on its own. But throughout its lifetime, it's been a place for me to try stuff. So I have had just a fantastic time trying multiple server architectures, multiple algorithms, and just all kinds of ideas throughout this system. And it portrayed itself as a very good example of something that needed to be thought about. And the volumes became a point where we started to have to scale very significantly. So it became a great test bed for that. The idea came, I think I was at a bar drinking beer with my friend Jack in 2003 in Syracuse, New York. And he said, there should be a website that accepts email. And I said, there's already such a thing. It's called Yahoo, or it's called Hotmail, or remember 2003, so it probably didn't say Gmail. And he said, no, one that accepts email for every single possible address you can think of. There's no sign up, no login, completely public email. So we thought about that idea, and that's really basically where it started. So the website, don't think of Mailinator as a normal webmail where you have accounts. You don't have accounts. It is a website that accepts email for any single address at mailinator.com. You can check any inbox you want. You can read any email you want. If this sounds insecure, that's the point. Okay? It's not even supposed to be slightly secure. The point is disposable email. And the idea was like this. When I explain to people, like say you go to some website, the New York Times or something, and you want to read an article. And they're like, sure, first give us your email, and we'll send you a link. And you think, well, if I give you my email, you're going to spam me forever. So right then and there, you pick something out of the blue, Phil123 at mailinator.com, enter it into the New York Times site. Don't go to Mailinator first. Think of it first. Then that site emails Mailinator, and the inbox is created when the email arrives. So then you go to mailinator.com, type in Phil123, there's your email, click the link, and never think about that again. So there's no user accounts, like I said. Anyone can read any inbox or read any email. No sign up, no login, receive only. And no attachments. Attachments are very bad. Attachments are very, very bad, okay, especially on the anonymous internet. So absolutely no attachments. And all emails deleted after a few hours. But think about it, that use case I just gave you, that perfectly works for a few hour lifetime email system. It's not there to just last forever. So as it says here, this allows for not billions, trillions, or quadrillions, it's trillions and trillions and trillions of possible email addresses. Okay, so how it's relevant to this talk is, again, it's been a test bed for me since 2003 to try server architectures. I was doing my PhD in Syracuse. I spent a lot of time in multi-threaded server architectures, and this became a great test bed to play with that sort of stuff. Eventually, as time went on, and we'll talk a little about that, it became a full-blown SaaS service. A SaaS service that customers are actually paying for. And the first thing is to say, well, wait a minute, why would anybody pay for that? Yeah. And that was my sentiment for a very, very long time. I had no idea how to make money off this thing. The customers told me. So we'll talk about that in a minute. So one thing I want to say is what this talk is about. This is not necessarily a talk about the right way to scale a system. This is a talk about how I scale the system. Over 15 years, trying architectures, trying ideas, seeing what works, crashing things all over. By the way, we were just talking about doing some QA, some testing. Not a single unit test in 15 years, okay? Thank you, Internet, for all being my QA testers, right? That's basically how, so just to give you an idea. That being said, I learned a lot along the way. I would probably do things different to some level if I started this again today, right? I've learned things. And some things I'm super happy I did it that way, and some things I'm happy I took the journey and went the wrong way, okay? So just keep that in mind. We're going through a journey here more than... So here's the great news. You can build a Mailinator clone in just a few hours. I did. That's how I built the first one. Go install SendMail. Go load the file in etc/vert user table. Set that thing to add your domain, catch all inbox. And now SendMail will accept email from any address at all and put it on your hard drive. Okay, so boom, you've got half the system written and done. And there's a million copycat sites, competitors. I'm careful about competitor because there is no business in disposable email. So if you want to compete, go ahead and feel free to spend, lose money too, please, you know what I mean? So then, of course, you got to get the email to the web. So sure, I had to write a simple website with an IMAP library that went to this local send mail. Probably I installed Postfix and some other things. Who knows? It was 2003, and pulled up the email, and there we were, and it worked just like that, just that fast. And I actually have a document I wrote a long time ago about initial server specs and stuff. So I'm actually accurate on those. The initial server specs was a 2 gigahertz Athlon, 1 gig of RAM, 80 gigabyte hard drive, and a 10 megabit NIC card. Okay, and I was only storing 20,000 emails. Even then, I realized, well, I can't store an infinite number of emails. I'm gonna have to somehow figure out what happens. And I created a FIFO system, first in, first out, that new email pushes out old email. And I just sort of had to make a decision, how much do we hold in this corpus at any given moment? And I picked 20,000 initially. So here was our first server architecture. Okay, I'm going to show a bunch of diagrams with these blue boxes, and anytime you see a box, that is a server. Okay, at this time, it was actually a server, a dedicated server. Can you imagine? You could actually, in those days, you could actually rent a computer, not these virtual computers, or not a container in a virtual computer on a computer. You could actually rent a real computer, right? So that was actually a computer. I ran SendMail on it. I ran Java Tomcat. I opened up port 25. I opened up port 80. And boom, there we go. Notice I don't say port 443. It was not HTTPS at the time. What did I know, right? So that was the entire server architecture. And it worked great, actually. So launch. I launched it, and I happened to, at the time, know Joel Spolsky in New York, and went to lunch, and I told him about this, and he thought it was cool. So thanks to Joel, on July 23rd, 2003, he posted on someplace on his very popular blog about it, and I got 6,000 users the first day. This is amazing, right? I mean, boom, we're off to the races. Off we go. I should put some ads on here. And eventually, of course, I did, which, of course, don't pay anything. But I didn't know that, you know? So off we went, and there was the first design. And the real idea was avoid spam, right? That you get all this, if you get your email out, you get spam. So pardon me, but our first motto of the site was flick a booger at spam, okay? I will show them, and down in the lower left, you can sort of see a semi-boogery diagram or whatever. But this was the entire site, okay? So we launched this, and I learned a lot of things right away. First of all, I realized, I mean, keep in mind, 2003, we all know anonymity on the internet today makes people do things they might not otherwise do. Well, 2003, it wasn't quite as well known, okay? So I learned about that right away, the crazy things people would do. Then I learned something else, that people would find, there were websites out there where they would say, hey, vote for your favorite band. Give us your email. And then all of a sudden I would get 10,000 emails voting for some band, right? Joe 1, Joe 2, Joe 3, Joe 4, Joe 5. And they would write some, whatever the comparable systems to Selenium was back in the day to automate this system, and they would vote for their favorite band over and over and over and over and over again, or something like that. Or they'd go sign up for, pick your, I'm trying to think of what, Facebook wasn't around yet, whatever was around then, sign up for 50 accounts or 100 accounts or whatever else. And what these sites then would go find that someone signed up for 100 or 1,000 accounts on their system. And that some person out on the internet, we don't know to this day who it was, did that. And they're mad. And they want to be mad at somebody. Now, they're going to be mad at that unknown person out on the internet? No, they're going to be mad at me, right? Because we provided the email. Now, when you think about that idea, what I realized then was, especially then, and still to this day, we tend to identify an email address as a piece of identity. And that's completely wrong. Everybody in this room has multiple email addresses, probably not all with your own name, right? I'm not saying you're pretending to be Bill Gates. I'm saying you're Red Stalker from World of Warcraft, right? And at yahoo.com or something like that, right? So email being identity is just plain wrong, right? They're available for free. Even Mail that gives you nothing, Yahoo doesn't give you, just quicker. I can go sign up for multiple Yahoo accounts, certainly, right? It just takes more time. Secondly, when you are creating a website and you create the sign-up system, you will face an immediate question. Do I want to make people sign up with their email and a password or a username and a password? And there's very few of the latter, typically. Most people have you sign up with email and a password. Reddit is an example of someone who signs up with username and a password. Okay? And if you sign up with username and password, the second thing you will learn is people will sign up for 10,000 accounts. Okay? And Reddit figured this out right away, and I encourage you to go try to sign up for 5 Reddit accounts. You'll be stopped immediately. Reddit put in a rate limiter. Duh, right? But people that write signups for email and password figure I don't need to write a rate limiter, because the act of getting an email address is an external rate limiter to the world. And I broke that idea. Okay? And again, they were rather mad at me. So I spent a lot of time writing anti-abuse code into the system itself. If they're not going to provide the rate limiter, which they should, they're still going to get mad at me, which wastes time in my day. So I wrote tons, and I can't imagine how many hours of working on Mailer was about anti-abuse code. And we'll see some of that. So, system limitations that I started to see as the service grew. Now keep in mind, when you use Phil123, forget about it, and go use Phil124 and then Phil125. New York Times never forgets about Phil123. They spam it forever. So we start to, if I have 10,000 users, we're getting 100,000 emails pretty soon, right? And the number of emails never goes smaller, it only gets bigger. So there's a saying I like that both good and bad software engineers will build systems that will eventually crash under load. Right? That's a guaranteed truth. Computers are finite. You only have so much bandwidth, so much RAM, so something is going to crash at a certain level of load. But good software engineers can tell you where it'll happen first. Right? So, and I certainly wasn't that person in the beginning, but I started to see these crashes and started to anticipate them and understand where it was going to happen. So, in the early 2000s, we did not have SSDs. We had spinning disks, and an average seek time at the time was about 10 milliseconds. Yeah?
Is there a reason why you didn't age out the email that was used? Like, so, like, at a certain...
No.
That inbox exists forever. Every single inbox exists forever and ever and ever and ever.
Okay.
What if someone a year from now uses Phil123? They didn't know that we used it 5 years ago. No, every email will exist.
Okay.
And in fact, there was a competitor that came up quickly, 10-minute mail, maybe a year later, and he gets a new domain every week or every month or something. That's his tactic, right?
What's the philosophy behind that?
His or mine?
Yours.
Well,
And why you didn't want to age out?
there was a romance in the amount of email I was getting. And the pressure it was putting on the servers. And again, in the beginning, the primary impetus for this project was me having fun designing servers. So if you're telling me I'm going to get 1 million emails tomorrow, that sounds great, right? From all over the world. So there wasn't ever a goal. We never filtered spam. There wasn't ever a goal to say, you know, this is spam, or this, we don't want this, or I'm going to try to... Now, if you're trying to DOS me or something, then yeah, I'll probably try to work against you, right? And we'll talk more about that, but that was never the philosophy. I never tried to slow the traffic.
Okay.
So, again, a disk seek time is like 10 milliseconds, right? So, we can do 100 of those inside of 1 second, right? But if you think about an incoming email does 2 things. One, at least, and I'm being very, very simplistic, it writes an email to the disk, and it deletes an email from the disk, right? Every single incoming email does 2 disk writes. That's at least 20 milliseconds right there. That means at most, this disk can accept 50 emails per second. End of story. Now,
except the reality is you have to at least double that.
Oh, absolutely, and I say that in your hand waving over many other disks.
Yeah, so I was going to say you at least...
Oh, there's indexing, there's B trees, there's all kinds of massive stuff that has to happen. So absolutely, I'm being very, very, lenient on that idea. So, and I thought about caching, but this is about the worst caching pattern you could ever have, right? New email, most emails never read, right? So it's never going to be looked at. It comes in, hits the disk, waits for 20,000 more emails to come in and leaves. There's nothing to cache, at least in an LRU sense. So the system went on, and it worked like this for a good year or 2 or 3, and eventually it started crashing at about 800,000 emails. Today, that's about 9.3 emails per second, and it started crashing on the regular. So I sort of, again, one thing you'll notice as a theme in here, user activity. We get about 40,000 users a day. Their activity is irrelevant. Compared to the incoming and outgoing email, their activity puts no load on this system, okay? So we'll just keep that in mind as we go. If we would have had SSDs back then, a typical seek time on an SSD is about 65 microseconds, so an order of magnitude quicker, we could have lasted a lot longer on an SSD. I don't think we could actually still lasted the volume we get today. However, memory is measured in nanoseconds. So spinning disks in milliseconds, SSDs in microseconds, and memories in nanoseconds. Well, an idea I got from Google at the time, Google stores the entire internet index in RAM, right? When you do a query, your query goes out to about 6,000 computers, hits all their RAM, comes back with the index and gives you a page. Why don't I store the email in RAM, right? Everybody always says RAM is cheap. Cool, let's store the email in RAM. So I thought about what would it take to do that? 20,000 emails, about a 4K average email size. And you gotta be careful, right? Some emails are a megabyte. And incidentally, I did do a cutoff at about 150K. I said, that's not what this is for. You can't send me anything over 150K. If you do, I'm just gonna drop it on the floor. Okay? So, but they could be 100K, right? But let's say average 4K, that's 80 megabytes. However, I still have to store indexes for inbox list. I have to store indexes for email IDs. Java is not known for its memory frugality, right? By the way, this entire system is written in Java. So I estimated about 130 megabytes of RAM to store 20,000 emails. So I went out and built a custom multi-threaded SMTP server. Thread per connection SMTP server. I've had many years of discussions with people synchronous versus asynchronous I/O. This is a completely synchronous system, and I've had a grand time tuning it the entire time. SMTP is a ridiculously chatty protocol. When you hear a web server do this many HTTP requests, think about HTTP. Give me a web page here. Give me a web page, there you go. Give me a web page, then you're done. That's the whole transaction. SMTP requires at least 5 round trips to send an email. Hello, hello. Mails from Bob, okay. Mails to Joe, okay. Here's the email, okay. Goodbye, goodbye. That's an SMTP transaction. I got it listed down on the right there. So if I say I'm getting 100 emails per second, that's really 500 messages per second, really. And not to mention, you know, the email could be 100K, it could be 1K, we don't know. So I wrote this SMTP server, like I said, basically it's just sockets. Sockets on up, okay? I abstracted sockets. There was a nice library that gave me the commands and stuff like that, but this is all pure socket I/O on synchronous threads. And I upgraded the splurged, went out and upgraded the server to 2 gig, figuring I'll need it. So now we look a little bit different. Basically, and this is the diagram I wrote down in like 2005 in my blog entry, so I just copied it. Emails come into the SMTP server, users come into the web server, there's your JVM and lots of memory to store. And they both hit that memory, right? Again, the web server is not the interesting active part, but nonetheless, it hits that heap also full of emails. Now keep in mind, now that all emails in RAM, guess what happened every time I needed to update the software? Well, crash. Boom, Control-C, and there goes all the emails. And I'm like, hey, it's a free service. You will be happy to know to this day, and since day one, Mailinator has run in Linux in a screen, a detached screen on the command line. Okay? If anybody knows what screen is, it's a way to leave your SSH session active. It still runs in there, and I have absolutely, on my desktop, had a browser over here, Mailinator's screen over here shooting up some sort of logs, and went to copy and paste something. Well, what's copy? It's Control-C. Oh. And I was in the wrong window and brought the whole thing down. So Control-C and kill is still how Mailinator is cycled to this day. Okay, so there was a lot of thought in this idea of how to store these emails, and this became an incredibly fun problem. I have probably rewritten this system a dozen, if not more times. Okay? So first of all, we got to be compact. RAM is limited, right? We have to keep the order of emails arrival. It doesn't have to be perfect, actually, but it has to be pretty good that new email pushes out old email. We have to be able to look up emails by inbox. So if I say Joe, I need to find all the emails in the system that are to the inbox Joe. And we have to pick up emails by ID. So if I want a particular email, I can get that one also. So you can see there's a couple indexes there. Now, for all the database folks in here, this is a straightforward problem. If you have a table, you set your table up with a couple nice columns here. We pick some ID scheme for the emails, a receive time, the to or the inbox, a from, Elon Musk sent us some email there, subject line, and then the email body. And then you set an index on ID and to, right? And then I can say, hey, on the to column, give me all the Joe emails, and boom, you've got your Joe inbox. And then when you say, I want the Bob 5 email, you got it. We index it. So it's super simple when a great piece of software like a database is doing this for you. But I have to do this in memory. So what am I going to do with this now? And there's, again, been many, many different thought processes to this. Here's one sort of recent incarnation. Now, if you look in the upper right here, keep in mind we are optimizing this data structure for the usage patterns. Fetching of inbox comes in at hundreds per minute. Fetching of emails come in at tens per minute. Adding email comes in at thousands per second. Okay? So that is what we are optimizing this for. Oh, and user deleting emails is ones per minute. All right? So first of all, if we are going to keep ordering, we have a linked list. I don't care how you call it. What do you want to call it in any which way, shape, or form? And somehow it's a linked list along the bottom. So that is keeping ordering. So every time we add an email, it goes to on the left to the head, and every time we get rid of an email, it goes off to the right on the tail. Right? Then we can have a dictionary or a hash map, depending what language you come from, based on the inbox. So we need to update that data structure. And then to query individual emails, we have another dictionary, another hash map that keeps the exact email ID. So we can query any one of these things. Now, we may have thousands of threads hitting this structure at any given moment. So those all have to be synchronized, right? All basically mutual exclusion. Database, you didn't even think about it last screen, just do a transaction, right? On those, you don't even do the transaction because it does index updates as a transaction effectively, right? So it's going to fix those indexes for you. We have to update our own indexes, so we have to do mutexes with all of this stuff. Now, that's all well and good, but when you got this speed of email coming in, those hash maps and dictionaries at times rebalance themselves, right? And that's incredibly expensive. That is a linear operation over the entire number of emails in the system. So those data structure rebalances are devastating. Then you got garbage collection, by the way. Thank God for the Java garbage collector. I create so much garbage in a second that, who knows how to keep up with it. So a lot of this stuff is going on. That is definitely a viable system. That would work. The threads can cause a mutex faster than a few thousand per second, which is more than what I'm asking the servers to do in other directions of other bottlenecks. So this is a perfectly viable solution. Other solution I've come up with, one more data point here is, usually whenever benchmarks or thought processes are put around hash maps, hash tables, or dictionaries, they go through normal usage patterns, which is something like 90% reads and 10% writes. That's a typical, just generic hash table dictionary sort of usage pattern. This is the opposite. 90% writes, not even 10% reads. Probably 98% writes and 2% reads, something like that. So a very, very different usage pattern. Like I said, I was always tinkering. I loved to write stuff for this. I wrote a data structure called a synchronized linked tree map. If you are a Java programmer, you're familiar with a hash map. You may be familiar with a concurrent hash map. You may be familiar with a linked hash map. This was a synchronized linked tree map, okay? And it was a very custom data structure, and it only had to index the inboxes. And it only indexed the inboxes to the first entry in the linked list of that inbox, so Joe. And then there was interlaced linked lists for the Joe. So I gave this talk once before and I got way too deep. I get way too excited about this. Okay? So basically what happened with this system though is now the data structure has to balance much less because it's doing inboxes, not email IDs. Now, email IDs change often. Inboxes don't change quite as much, right? Second of all, the interesting thing about a tree map instead of a hash map, you can do sub-range queries. So later in the product's lifetime, you can now, and I don't allow the public to do this, but you don't have to search on Joe. You can search on Joe star, and you will get email for every single inbox that starts with the characters J-O-E, right? It changes sort of the paradigm. Well, first question two, why aren't we compressing the emails if we care about saving some room? This didn't work very well. Okay, first of all, in 2003, I had a different kind of CPU, right? So trying to do certainly like something like 7-zip was never going to work. Second of all, emails compress pretty terribly. All compression algorithms are typically based on starting to look at the data and building a dictionary of compression as they go along. Emails are often very short, and by the time you're done, there's a useless dictionary has been built, and then we're done. And then we go to the next email, which is completely different. Second of all, a good portion of emails come in base64 encoded. You ever try compressing base64? It's already entropy, right? There's nothing to introduce into the system. So I did also, the headers of emails, which I'll show you in a second, those did compress a little bit because they have they're key value pairs and the keys are common. So I tried to build a custom Huffman encoder, which sort of worked, But it sort of fell into the category of I got way too complex and got in over my head and had to back it out and settled for not using it. If you look at an email, though, this is a typical diagram of an email in raw form. The top has all these headers. Received, from, date, subject, all that stuff standard on the left-hand side. And all stuff on the right-hand side is obviously variable. And it's very variable. For example, the date, right? It's going to change constantly. I mean, there's never going to have the same date up there. The bottom half, though, is where the body came in that I had trouble compressing. And notice, even in a simple email, hey, Joe, how are you today? You've got all this other content type, blah, 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 that gets tries to fit into the compression algorithm and doesn't fit. But what we would see is an email blast of 10,000 emails, all with different headers, because they go to different inboxes with different times and all this other stuff, but the bodies were all the same. They were a newsletter. They were a spam. They were something like that. So the bodies, although they were tough to compress, they turned out to be the same exact thing. So what I did was reuse the bodies. They say if you go buy a song on Spotify or Amazon, you don't get your own copy on a disc, by the way. They have one copy of Pink Floyd's Dark Side of the Moon, and everybody listens to that one single copy, right? Why would they? I'm sure they have backups. But I mean, why would you have multiple instances? So same thing here. We can get 10,000 emails and truly only store it once, as far as memory goes. Now, there's a lot of computation to figure out it's the same email again, but nonetheless, we're able to save a ton of RAM this way.
Yeah. Did you at all bother to look at the size and say that things like emails less than 4K weren't worth?
Absolutely. Didn't even try to compress those.
Yeah.
And that's why I say here, maybe compressed email body. Yes, exactly. And especially if we start to see, well, I guess it doesn't matter as much, but if you see a lot of instances, you can compress it then or something. But there were a ton of heuristics exactly around that, whether compression was worth it. So, all right, everything is great. The system went from crashing at 800,000 emails a day to getting 1 million emails a day, super solid, never crashed except for me screwing around, hitting Control-C by accident. The disk, I don't need to tell you, just turned off, right? I'm not putting anything on the disk anymore. So the CPU and RAM, that's all we're doing. And the CPU actually wasn't very busy at all, okay? And that's sort of the dirty trick on this stuff. Unless you do a lot of sort of sloppy code, getting data and putting it in memory is pretty straightforward. So I thought everything was going okay, and I noticed at first we're getting 1 million emails a day, and then after a month we're still getting 1 million emails a day, and then after a couple months we're still getting 1 million emails a day. Of course not exactly, but I mean around there. And the site seemed sort of sluggish too. And customers kept emailing me that their emails never arrived. They don't know what they're talking about, right? So I could check the code, I checked everywhere I could think of to say, why is this limited to 1 million emails a day? There's nothing magic about that number. So Server Beach, where I was hosting, had a sale. And they said, hey, for free or for $10, we'll upgrade your network card from a 10 megabit card to a 100 megabit card. Cool, do it. The moment they did it, we went to 3 million emails a day. So we were absolutely saturating the 10 megabit card in the back of the computer, right? No wonder the CPU wasn't busy, right? It could not get enough bandwidth. So immediately shot up to 3 million emails a day. And I've got the stats there, a 10 megabit NIC is 1.25 megabytes per second, and 100 megabits, 12.5 megabytes per second. So every system has a bottleneck. Remember I said every system's going to crash, every system has a bottleneck. It's not often your network card, certainly not these days, okay? But it was for me and it was for them. And this, you'll see this as we go through, this really shaped my thought process on the volume of network traffic that was coming through. And I made a lot of design decisions, for better or worse, to be afraid of that. Okay, so things I learned. Every user or email that hits your system is part of a concerted denial of service attack. If you have a website and a user comes in, they are using some of your bandwidth, they're using some of your CPU, they're using some of your RAM. If you hit your database because they hit your website, they're using some of your disk, right? At my last startup, I had all my engineers pledge that they promised to say they're sorry to all the users every time they hit the database. Because they can get so much done with CPU and RAM. So hit the database when you need to, but respect it. Because it's orders of magnitude slower than the rest of this stuff. Okay? It is much harder to DOS a system if you're only hitting RAM and CPU. That's why if you have a blog, you cache the entire blog into RAM using Varnish or Nginx or something, and it's almost impossible to crash that thing, okay? If your system, if their request causes a database write, I can crash your system, right? Give me Apache Bench and I can crash your system. The database read, the cache is probably going to save you. So now, keep in mind I'm not using SendMail anymore. Keep in mind I wrote the SMTP code. I probably shouldn't be writing SMTP code, right? So first thing I forgot to do was I never checked. You know, they say, hello, here's an email. I say, cool, who's it for? And they say it's Bob at Mailinator. I say, great, send it in. Most SMTP servers will make sure that you configured it to say, accept email only from mailinator.com, right? I forgot that if statement. So if you called our servers and said, here's an email for billgates@gmail.com, sure, we'll take it. We'll put it in Bill Gates' inbox. So immediately, I realized you could send an email with any domain you want to our SMTP servers, and the system will accept it happily. I thought it was a bug, and I realized it's a feature, right? So I wrote a blog article. Have your own private mailinator. Put any old domain you have, point your MX record to our SMTP server, it'll work just fine. If you own, MountEverest.com, point it to our MX server, and you can use Bob, Joe, Phil123, you can use anything you want at MountEverest.com. It'll arrive in the mailinator system just fine. Now,
you Control-C it and you drop everything.
well, of course. Yeah, well, under normal terms and conditions, absolutely. I have a URL there. You probably can't read it, but again, you can download these slides if you want. There's about 1,900 domains pointing to Mailinator last time I checked. Okay. Also, what I discovered is in the early days, when people brought up SendMails and mail servers, they would misconfigure it as an open relay, which basically was similar to what I just described. You could set it up for yourcompany.com. Someone would say, send an email to Bob at Gmail. A misconfigured email server will say, sure, and then try to forward it off to Bob at Gmail. It'll act as a relay. And that's completely broken, right? And the reason was, once spammers found these things, they loved them because they could use your system as a relay to send spam. So I started getting emails from security people saying, hey, you've got an open relay there. You're forwarding to everywhere. And I'm like, no, I'm not. I'm just taking it in and saving it. But they didn't know that. So I got all these security people angry at me that we have a complete open relay. So Mailinator immediately started getting flagged that any email from, keep in mind, from Mailinator is spam. I'm like, well, there is literally no way to send an email from mailinator.com correctly. So yes, it is spam. That's another feature, right? I'll take that too. I'm perfectly fine with that. So I got 2 instant features out of my bugs. So everything is great. Still running on a single server, a few million emails per day, a few thousand users per day. Then I went on vacation. And of course, if you ever want to figure out when your hardware failures are going to happen, you go on vacation. So my system started crashing for some, slightly faulty hard drive, right? Those are the worst, right? Because if it just crashes, they'll go fix it. But it started sort of crashing on and off, and I got a lot of angry users. So I need to make my infrastructure redundant. And this is where we start to scale it. So the first goal of scaling the system was not because of load. It would have been, but it was really because of redundancy. So just to remind you where we are currently, is one machine with everything inside that same JVM. I'm going to break it up. So I'm going to create, first of all, I'm going to create 2 web servers, right? This is a classic paradigm, classic idiom for scaling your servers. You scale out horizontally your web servers. They don't know about each other. They don't care about each other. They're fine. If you're not familiar with HA Proxy, it's an incredibly awesome load balancer that I put up in front. So it marshals all web traffic. It also handles the SSL certificate and goes ahead and sends the traffic to one of the 2 web servers. If one of those web servers go down, HA Proxy says, fine, I won't send any more traffic there. I'll send it to the other one, right? So HA Proxy is a fantastic tool. And there's a bunch of them. Nginx will do it too. HA Proxy is, I'd say, probably later weight. Then, let's break up the SMTP servers. So unlike most records, you can do round-robin DNS on a website, but that's sort of less common. MX records are built to have multiple entries. Thank you. So I can literally say I have 5 SMTP servers and actually put those IPs in for everybody that wants to send me an email will look up my MX record, find out what my IP address is, my SMTP, and they got a choice of, well, in my case, 2. And that's actually the truth. So that was actually I thought I'm done. Like, this will load balance everything I care about. But we have to ask this question is, how do the web servers now get email from the SMTP servers, right? And mind you, an email for Bob might have gone at SMTP2, and we don't want to look at SMTP1 for that. So how do we find out where that is? Well, the initial thought, and I actually had some people suggest this to me, was some sort of centralized store, right? And here is the crux of all scaling and scaling issues ever known to man, is this idea. I would invite you to notice that when you see HA proxy, you see two arrows going out in different directions. That's called a splitting of traffic, right? Now look at the SMTP servers, have two arrows going into one place. That is an aggregation of traffic. So whatever load those SMTP servers under is half of whatever load this storage system is going to be in. And I have listed in there, I could use Memcache, I could use Redis. These are all in-memory stores. I'm staying with you could use a database here too, but we've already agreed we're staying in memory. So Memcache, Redis, you could also use Mongo in a RAM disk. That's another option. There's all these different options, but if we're aggregating all the data in one place, we're causing all that stress. I didn't like this solution at all. And the solution became to basically let the SMTP servers keep the data. Whatever happens in the SMTP server stays in the SMTP server, right? Now the SMTPs they get the email, they keep the email. The only downside to this is every web server now has to talk to every SMTP server. That's not such a big downside, actually. I'm probably only going to have several, and if I ever get huge, even if I have 100, that's actually still not that big a deal. So that's the direction I went. Now, the SMTP servers know nothing about each other, and that's the right answer. The web servers know nothing about each other. This is all very, very sort of solitary systems. Any one of these servers, except for HA proxy at the moment, could go down, and the system would stay up. Any two servers, and we start to have a problem, right? The MX records did not work. I mean, they did work. They do naturally split the traffic, but by no means even. So if I'm doing a first in, first out system, SMTP1 always moved faster, right? There was always more email coming in the first choice. So it didn't split the traffic evenly. And I could have lived with that, actually, but I decided not to. So I basically went to this solution, which, first of all, on the web side, we went behind Cloudflare. If you're not behind Cloudflare and you don't mind Big Brother, get behind Cloudflare. I did not host all this on AWS or Google Cloud. This is hosted on Linode nowadays. And Linode, for sure, I'm sure you can do this elsewhere, is I set up redundant HA proxies that are on standby IP. So if my primary web server goes down, my primary HA proxy goes down, load balancer, there's another machine there going, wait, where'd that IP go? I know, I'll become that IP. And it then just starts taking that traffic and proxying and has a redundancy layer for that. Also, the magic of HA proxy, it can load balance not just web, but it can also load balance SMTP, which is pretty awesome. So now there's HA proxies in front of the SMTP servers to basically round robin the load between the two SMTP servers. So I still have the MX records distributing them, but now HA proxies distributes them also. So needless to say, the most efficient programming team in the world is one programmer, right? Because you don't have to talk to anyone. And as soon as you go to two, you got to have a meeting, right? I mean, that's the way it works. And the same thing works with servers. So if you have one server, things are easy. When you have multiple servers, you got to figure out all kinds of new stuff. And the first problem was, how do the web servers find the SMTP servers? So I did what everybody does at first. I hard-coded the IP addresses in the code, right? And that works until you got to change something, right? And then it doesn't work anymore. So I started looking into solutions for this, and there's many. There's very quick databases called, I shouldn't call them databases, I guess they are, key value stores like etcd or Consul, which are just there to provide service discovery and a little more. But they're there to provide internal system service discovery. You'll see this very often in a Docker situation when you got a lot of containers. What does this container do? He registers with those services and says, I provide web services, and then everybody knows that. So I went much simpler. Like I said, I host in Linode, and you probably can't see it, but in the upper right, for any given server, you can give it a tag, any tag you want. You say, this is for web, this is for my Aunt Jane, this is for whatever. So now in Linode, if I fire up a new SMTP server, get it fully configured and all the rest of it, the entire system will utterly ignore it until I add that tag. And as soon as I add the tag, all the servers query that Linode API every 5 minutes, and all the web servers will discover this new SMTP server. And the SMTP server will discover that some web servers are going to talk to it. And they all agree to talk and they connect. So it becomes very seamless, and we didn't have to install yet another piece of architecture. I do, as we go through this talk, I keep doing it, but I really tried not to install more software. I either tried to write it myself or get away without it. Second thing I found extremely useful was a package called JGroups. There's a project, a much bigger project called Apache Ignite, which provides what they basically call a fabric. Or you could think of it as a multi-server heap, which is basically a memory space that all your servers share. A memory space all your servers share. If you put a dictionary in that space, all your servers see that dictionary. That's pretty cool. Well, one thing that thing has is, because it can communicate in that fashion, leader election. So out of all my servers, one can become elected a leader. These are actually a terribly, amazingly hard problem in computer science, and JGroups will do this for me. So it finds the leader. And one other problem I have now is batch jobs, right? There's always some batch jobs to clean up some things or to do some stuff. Where do I decide where those run? Typically, you install yet another server with quartz on it or some other sort of job scheduler. I didn't want to do that. So I basically put all the jobs in every server as a thread, and whoever the leader is the one that runs it. And if that server goes down, someone else is elected leader, and those jobs still run. So that became very useful. And then also they were able to store some hash maps, which became very valuable on the part of that abuse code. So they were able to share information to say, this IP is really being a jerk, and sort of talk to each other in that way. So everything's great. The system is running like clockwork. Only thing that brings this system down is me hitting Control-C, right? Support emails from users start to increase, but not for system issues. They're mostly other business users asking for features, which, no one on the internet understands. Free means you don't get support, right? No one understands that. None of us understand that. But I start to think, hey, we could probably charge for this, right? But why are people using this? And as it turned out, this became incredibly useful for QA teams. If you're testing your sign-up system, you use your Gmail, and it doesn't work because you got a bug. And then you use your Yahoo, and it doesn't work because you got a bug. And then you create a new Yahoo, and that doesn't work because you got a bug. And I'm walking in saying, I'll give you an infinite number of email addresses that work. Here you go. So QA teams started using this once I finally started looking at the traffic and realizing it became probably the majority of the traffic. To have thousands and thousands, an infinite number of email addresses, for all intents and purposes, infinite number of email addresses at your disposal. So cool. What are we going to give to these? We got to upgrade something, right? We got to make some features that are subscriber only. Well, first of all, privacy. They don't want to send their stuff into the public domain where anybody can read it, even if it's unlikely someone will see it. If you're running a healthcare company, that's not good enough. So we give you a private domain. You can basically take any domain you own and point it to a specific way in our system, and now all that email is private, and you get every single inbox. We also give you a new looking inbox. This looks like a standard inbox, and pardon me for the size. The thing you can't see is this column right here says to. In your Gmail, it doesn't say to and then you 50 million times, right? Because it's always to you. But this is an inbox that shows the email of an entire domain at once. So you get to see every single email you want. And of course you can search. You can still say, I only want to see to Joe, or I only want to see to J star, I want to see to test or test star, or to everything. So we give you not an email address, a domain full of email addresses, okay? And obviously we can't store these emails in RAM anymore, damn it, right? That's a problem. I actually have to figure out how to store these somewhere, because paying users are going to be mad if they lose their emails.
And you get Control-C.
Yeah. I still need to be able to hit Control-C. Then also, they automate these tests, right? They do their sign-up system through Selenium or something to automate sign-up of their system every single day, right? All software is a massive Rube Goldberg machine, and you change this over here, and you'll break sign-up over there. And you never would have guessed, but that's how it works. So they can do that with Selenium all day long anyway. But we go ahead and now give them an API. So we effectively convert SMTP to JSON, right? So you can send an email and pull it out with JSON. So they can write automated tests in any language they choose, pull the email back. They can query the inbox and pull the email back when it's there and get it in a JSON format. Then there was this idea of SMS. Why not disposable SMS? Well, actually on MailNator now there's one disposable SMS number. Those cost money, so I can't give you an infinite number, okay? But there is one public disposable SMS number on the site right now, and paying users can get all they want. They can get as many private SMS as they want. Same exact thing, they want to test SMS as part of their QA process. How about a rule system? Email comes in, we auto-route it. We automatically route all emails to the inbox Joe to Slack. We automatically route all emails to the inbox Bob, by the way, Bob at my private domain, not public, at my private domain, forwarded to my Gmail. Or every time an email arrives in Sam at my private domain, search the HTML and click all the links. Because I was just going to click the links anyway. So why doesn't the MailNator system just click the links? So we can set up a rule system to allow these emails to fly through. But you know what we need sign up. We need login. We need forgot your password. We need uptime guarantee, security, and support. So how do we do it on the architecture side? So far we're here. So first thing we need is user records, right? So simple little database, okay? Add a database. I have that green, that sort of flat green line say they're a replicated data store. There's not two databases, there's one database, they're replicated, so obviously if a disk goes bad, and not to mention it's backed up, but there's a hot backup of a normal database replica. And that database is under incredibly low traffic. It's just logins, it's just signups, it's just, it's not a lot. Compared to the other stuff, it's just nothing. So that was not really a major concern. But now, where are we going to store the email? Okay, yet another database, okay? So, we get some bigger machines. This diagram now, this is the thing I tried to avoid 10, 15 slides ago. I have multiple lines going to one place. And again, there's two machines there that are replicated just for redundancy. It's not anything else. So I benchmarked those systems. Incidentally, the SMTP servers in the public system, I benchmark at about 3,000 emails per second. They can handle about 3,000 emails per second. This database system I built, and again, it's got to be that same thing, first in, first out. Although it is still first in, first out. Every user gets a certain amount of storage, and they agree that it's going to be first in, first out. But also, it's got to have indexing and all the other stuff.
That's true for paid users. They still have.
Well, they have you even have a storage size in Gmail. It's just 15 gigs.
I'm just curious.
I don't give you anywhere near that much because I'm a small.
Right.
You can get whatever you want with mail. Right? I mean,
You can pay.
if you have the money, I have the disk. You know what I mean? Like sort of thing. But again, the use case is QA and tends to be very short. So even with a gigabyte, users tend to be good for forever. But again, you can get whatever you want. But the paradigm still. I mean, what's the other option? I start bouncing your emails. Right? That's what Gmail would probably do. And I don't think their automated tests want that.
No.
I think their automated tests want, get rid of the email from 2 weeks ago. So again, I've introduced this bottleneck. And indeed I have. However, the good news we can do is we can shard the databases. All right? You can shard on whatever makes sense. So I literally could pop up 4 completely separate database systems that know nothing about each other and say all users who have a last name between A through G use this database, and all users that have a last name between H and M use that database, and all that end through S and this, and just shard the traffic. And I can do this forever, right? And I hope I have to do it forever. It's a great problem to have. If I have that many users, I'll just keep buying more and more database systems. Or another one here. I can shard them on customer usage patterns. I can have many, many, many users on the one on the left here that is less than 1,000 emails a day users. I can have a few less users on this middle one, 1K to 10K a day. And then on the very right-hand side, just a very few users, the big customers that send me more than 5 million emails a day. You can shard on whatever you want, but this is scalable. It's infinitely scalable, right? Because we can shard based on anything we're interested in. The only trick would be everybody needs to be in on the sharding. And by the way, a Mongo or a Cassandra or so, they all will do sharding for you, right? And I very often see people go that route. I've also seen, I'm not going to say why because I don't know, but I've noticed systems at scale tend to pull the sharding back into the application layer and make the decision there. So all I'm saying is people smarter than me seem to bend in that direction. Although all you got to do is install a couple Mongos and say shard and it'll do it for you too. Okay, one other issue I sort of ran into is I'm sharing SMTP servers between public and private users. Public is the Wild West. All kinds of crazy stuff happens there, and that sometimes impacts the performance of private users. So I just want them isolated, right? So I give them their own SMTP server. I give them a new MX record to use, mail.privatedomain.com, and I send them to a different HA proxy, which still has redundancy to the public's, but really completely favors the private SMTP server, which is not particularly busy. Okay, so that just sort of gets rid of that bottleneck, that danger of bottleneck. All right, everything is great, right? Subscribers get their own private mailinator. Public users still get their public system. One issue I ran into right away, I told you that user database basically got no traffic. Well, now all of a sudden, every incoming email that wasn't to mailinator came into some other domain. Was that a private domain, or was it one of these 1900 that the world just used? I had to go hit the database to find out. So all of a sudden, I was hitting that database for every incoming email. Well, that's not going to fly. So I created an in-memory replica. So when my databases come up on several different databases, the Java system basically calls the database and says, "Hi, I'm another database. I'm another replica," and the database doesn't know any difference and causes the entire database to become replicated in RAM. So now, depends on the size of your database. But the private domain database is just paying customers, which will be in the thousands, right? I mean, we can totally house that. And of course, now we're just accessing a hash map. And of course, anytime anyone updates their private domain, because we're a replica, we'll get the update seamlessly. All right, big idea, WebSockets. We ran another problem. You go to Mailinator, you go to the Joe page, you look at the email there, your coworker says, "Let's go to lunch," you go to lunch. You go to lunch. That web page queries my server for new email every 5 seconds, right? That's what email program web pages do. They tell you when a new email has arrived. So now if you got, let's just say, 2,000 people out to lunch, every 5 seconds, that's 24,000 web hits a minute, or 400 per second. For nothing, right? For absolutely nothing. They're not even interested. They just left the tab open, okay? So let's create a WebSocket. Just a proper socket to the servers, okay? Now, one thing I can't show you, I apologize because I can't have my laptop, but reshape your thinking about how Mailinator works in the sense of we tend to go check an inbox. We check Joe. Now, flip your thinking over to Twitter. Sure, you can go check, whatever, Bill Gates on Twitter, and you'll get his inbox. Or you could just go look hash Microsoft, and you'll fly across 1 million inbox, Twitter handles, right? But that's exactly what the Mailinator email stream is. It's a pub subsystem where you are subscribing to inboxes. So why not allow you to do that in the main system anyway? You're not looking at the Joe inbox. You're subscribing to the Joe channel, all right? So we need to build a pub subsystem where we publish every single incoming email and allow people to subscribe to it through a web interface, which then goes all the way to their browser to a WebSocket, okay? So to do this, I implement Redis. And I, of course, wrote my own first, and that didn't work, or probably worked a little, And Redis is just a wonderful piece of software. So I implemented Redis, and I'll show you that diagram in a second. But each SMTP server gets its own Redis. So on the same server, remember, I'm really scared to let email traffic leave that server. That's an irrational fear. Still have nightmares. We don't let it happen. So now the Redis is on the same server, and the SMTP server communicates to Redis over localhost, right? No real networking happens. And it publishes to Redis, not the whole email, just the to, from, subject, and date. No email body. And none of that data leaves that server unless a web server comes along and subscribes to the Redis for the Joe inbox. So again, this is where we just left off. You're getting seeing a theme. I want to show you where the diagram looked like. This is where we just were without WebSockets. And then with WebSockets, each SMTP server gets a Redis. And we get a bunch more lines here. So everybody's talking to the different Redises. The SMTP servers have a line there. And now what happens is when the user hits the site, they connect to the web server. The web server then goes out to the SMTP server and says, well, give me all the email you have in memory for Joe. And it does that. Then it goes out and simultaneously goes out to the Redis server and subscribes to the Joe inbox. And then starts feeding those emails alongside. So if I go here, you see this little green dot here, Mailinator stream connection status. You are literally connected to Redis from this browser, right? Now I proxy it and try to prevent abuse and all that other good stuff. But so you are literally connected to a Redis pub sub. And it's a little bit of, the interesting thing about that is, if you've heard about how I'm storing these emails, we have a queue of messages. A message queue. Right? There's a million pieces of software called message queues. ActiveMQ, ZeroMQ, Kafka, Polaris or Pulsar. There's a billion of these things where it's built to store a FIFO queue of messages that just go through the entire system. And I opted to use none of those because, well, for lots of reasons. But this is the closest thing I've come is using this Redis-based Redis pub subsystem. Okay, so now we've got WebSockets working. Everything is great, right? Seems like everything's great. Actually, I have no idea. Because I had, at this point, no monitoring whatsoever. The system's up, I assumed it's working, right? That was about it. I had no idea what was going on inside the system whatsoever, so I wanted to add full application monitoring.
Well, about what year in your evolution was
This is probably 2011, 2012, 2013, somewhere in there, maybe. So, if you've ever heard of ELK, Elasticsearch, Logstash, and Kibana, and also its sort of cousin Grafana. This is all this stuff's free open source analytics database. The analytics database is very similar to my problem. They get a ton of data it needs to be aggregated and it sort of shoots out the other end without being queried individually like a regular database. So, what are these things? Elasticsearch is a very cool, mostly free search engine for JSON data. Written in Java, wonderful, wonderful system. You need a pretty beefy machine to run it, but super robust and super awesome. Logstash is a system where you take your structured program data, right? If you're sitting in your code, you've got structured program data, all your variables. You know that name, you've got a name variable. You know what name variable means. And if you've got address, you know what that variable means. And then you take that structured data and you unstructure it and put it in a log line and say the sign up was from a guy named Bob. And then Logstash will restructure it and put it into JSON. So it can put it in Elasticsearch. That sounds really dumb to me, so I'm not using that. Okay? So I built a system to take my structured data, put it into a JSON payload, and send it straight to Elasticsearch. That makes way more sense to me. Okay? Then Kibana and Grafana are two front ends for Elasticsearch. And I'm just going to show you Grafana today. They're both great at, Kibana is a little more like Google, lets you search engine-y sort of thing. Grafana, you'll see in a second, looks a lot more like, it's all graphs. Okay, so here's where we were without trafficking. Add 2 more servers. And now we've got the one on the upper left here by the web servers. That's tracking user activity. Now, we don't track any PII. Okay, we don't track IP addresses. We don't track any of that sort of thing. I do want aggregations, though, of what's happening inside the system. If someone's signing up for 1 million Facebook accounts, I want to know that. Right? Again, I don't know who they are. I don't even try to find out. I'm just going to stop them. The one on the right, though, is tracking every single incoming email. Not the email bodies, just that same thing that went into Redis, just the subjects and the IPs. IPs of who's sending email, so it's another SMTP server, not a user. Okay? All right, so across the top, on the upper left, we have three SMTP servers, and you notice one has number of emails has 1.6, and this is just in RAM. The other 2 are storing about 530,000 emails each. So we're keeping about 1 million emails in RAM right now amongst those 2 servers. Okay? If you notice the next, going to the right, emails received in the last 24 hours, 7.5 million emails came in today. Okay? Then we go to the right again, 3.5 million were delivered. What does that mean? 3.5 million were delivered, but we got 7.5 million. We rejected all the rest. So basically, Mailinator sits there and says, it watches subject lines, which is a little dangerous because it has to parse every single incoming email. And says, I've gotten 1,000 of these emails saying, buy your Rolex watch. I think that's enough. and it drops them on the floor. By the way, keep in mind, there's no banning on the private system. That's your business, right? This is really just about the private or the public system. We did, however, deliver 500,000 private emails today. Okay. Then in the upper right, notice the max rate we've seen in the last 24 hours is about 1,700 emails per second. So this is what MailHitter has got today on the public side. Incidentally, I worked with researchers at some point, and I get this still from, I just worked with Georgia Tech last summer. There was a cybersecurity class that asked for API access to the MailHitter system so their students could go analyze the spam. And we'll do that all day long. But I actually tried to talk to sort of more serious researchers, and it turns out it's not that good anymore. I think you just saw we got 7 million emails today. We used to get about 30 million, very regularly. I think the spammers know we're not worth the trouble and have sort of knocked us off a lot of lists. Clearly not all, but so MailHitter today, we have a team of engineers, we actually have sales, we actually have marketing, we have support, about 3 to 10 million emails a day, depending, of course, way down from 20 to 30 million. Biggest public spike ever saw was 200 million in a day, and about 2,000 to 3,000 emails per second. And it's very, you gotta be really careful with that. When I say 2,000 to 3,000 emails per second, how big were the emails? Clearly they have to be small, even if I'm talking about such numbers, right? How many SMTP connections? How many different IPs came in? So it's very hand wavy. Don't get too caught up that there's some quote that that's what we're doing. But that is what we received those days. About 30 to 60,000 users on a regular day, 100K if we hit some news. Thousands of corporate users, millions of API hits. All Java. I hate frameworks. Very, very base stuff. Raw servlets, raw JSP, SMTP right at the socket level.
So you anecdotally attribute the reduction in traffic to the spammers realizing that you're not a good target anymore?
Yes, that and corporations realizing we're a bad target.
Okay.
Because when I was at LendingTree, on one hand, they were fascinated I was MailHitter and asked for a free subscription. And on the other hand, they said, how do we ban MailHitter? Right off the bat. And I'll talk about that right now. So the first thing I heard when I developed this in 2003, they're going to ban you. Everybody's going to ban any email at mailhnitter.com. And that has just absolutely never happened. Okay? You could still use MailHitter in a heck of a lot of places. But when they first did this, I sort of took it personally. Right? So how do I fight back about this? I know I'm going to go buy some alternate domains. Again, we can point any old domain here. I'll buy some alternate domains, put them on the website, and let people use whatever they want. So I bought notmailinator.com and reallymail.com and veryrealemail.com and put this in your spam database. All kinds of alternate domains. And I used to put them on the site. And people would say, oh, can I have a whole list? I'd really like the whole list so I know, what to use. In other words, so they know what to ban, right? They would email that all the time, and I would say no. So I went ahead and basically every time you loaded the home page, I'd show one of them. And I had a list of about 20 or something. So you kept refreshing, and you maybe get a different one or whatever. And then I started to notice people scraping the home page over and over and over and over to try to get those entire lists. And I thought to myself, what happens when they scrape that list? They scrape the list, they get the alternate domain, they put it in some database, and then every time someone tries to sign up with that domain, they query that database and reject the sign up. What would happen if something like gmail.com got into that database at 2 a.m. on a Sunday morning after a night of drinking? But boy, pagers would be going off Sunday morning saying, no one can sign up from Gmail, what's going on, right? I'm not saying that ever happened, I just always wondered that, But eventually I realized it's your site. If you want to ban MailHitter, go ahead. And I don't even advertise the alternate domains, they're sort of expiring, I'm not really worried about that, that's really not that interesting. It's your site, if you want to block those domains, go ahead. To me, I have my Gmail account, I have my backup sort of junk Yahoo account, and MailHitter is my third tier real junk, right? And sometimes I want to use that. And if you don't let me use that, that's cool, I'll go elsewhere, right? And so my point being, it was their choice. Now, since MailHitter's been out, like I said, there's probably 100 copycat sites that have come on. There is a nice list on GitHub of 23,000 disposable domains. So if you want to block disposable domains, certainly don't stop at MailHitter. Okay, there's plenty to go around. Now, I also found this pretty amusing, and we didn't discover this until seriously 2 months ago. Okay? I'm going to give you a lesson in defensive programming. Now, let's say your boss walks in and says, hey, I just found out people can sign up for our website at mailinator.com. I want you to ban all email addresses at mailinator.com. So you write some code, something like this. If the email address has a domain that equals mailinator.com, ban it, right? Feels good. We got it, right? Perfect.
Wrong.
Wrong. That's right. Remember we said Mailinator's SMTP server accepts email at any domain? Well, this includes subdomains of mailinator.com. So, public Mailinator not only accepts email for anything at mailinator.com, it accepts email for anything at anything.mailinator.com. So anyway, the right way to write this code is don't use equals, use ends with. But that being said, in about just complete anecdata, about 90% of sites have written the code wrong. All right, well, thank you very much. At least I got some stickers for your last.